Hindustan Institute of Technology, Department of Aeronautical Engineering, UAV Systems. Presented by S. Tamil Selvan, Assistant Professor. Unit 2, Unmanned Aerial System Components, UAS. Payload Installation and Utilization, Propulsion, Onboard Flight Control, Communications, Telemetry Tracking, Launch/Recovery Systems, Ground Control Stations, Troubleshooting. UAV into two parts: aircraft and payload. Left side includes the UAV autopilot, which provides attitude and position information to the payload and also receives commands from the payload. 3 communication systems that a typical autopilot uses: a command and control system continuously communicating with a ground station operator, a global positioning system, GPS, which receives satellite signals, and an RF link to a remote pilot. The right side of the figure contains the typical payload subsystems: a sensor subsystem to acquire information in flight, a communication subsystem for providing situational awareness to the ground operator and to receive commands from the same operator, an onboard computer subsystem for analyzing sensor data, executing tasks, and providing useful information to the ground operator, and a power distribution subsystem to support the above payload subsystems, typically using batteries. Payload requirements. These payload systems must meet the volume and weight constraints dictated by the chosen aircraft. The left image shows a multirotor aircraft. Due to its limited payload capacity, much lighter payload systems are chosen. The right side is a fixed-wing aircraft with much higher payload carrying capacity, matching payload to vehicle capability. The left image is a multirotor aircraft with a Raspberry Pi computer acquiring images from the camera and sending them to a ground station via the low-power Wi-Fi radio. The right image is of the bay below the wing on a fixed-wing UAV. It can carry a gimbaled EOS sensor, which provides analog images to a frame capture board for the onboard computer image processing and analysis. Imagery and mission status is sent to the ground station over a higher power Wi-Fi radio. Payload mission requirements. What is the flight duration required for the mission? What is the specific task or a list of tasks required of the mission? For example, searching for specific targets, setting up surveillance posts, providing a communications relay, etc. What are detailed mission subtasks? How large is the search area? How long will the payload systems need to operate on the ground before the flight commences? How many UAVs will be in flight? If multiple UAVs, how is collision avoidance incorporated? For a small UAV, altitude separation is typically used so that avoidance hardware isn't necessary. What are the target characteristics and the accuracy of localization for the ISR mission? Moving or stationary targets, number of targets, target separation, size, shape, and color of targets. What are the allowed frequencies that can be used for communications between UAVs and the ground station? What is the maximum distance from the ground station that the UAVs will be operating? Will other devices be operating in the same area that can cause communication interference? What are the situational awareness requirements of the ground station operator? Imagery refresh rate, image quality and size, UAV position, mission status, and health. What are the environmental requirements, vibration, shock, humidity, and temperature? Questions? 1. What type of drone requires a runway for takeoff and landing? A. Fixed wing. B. Multirotor. C. Single rotor. D. Quadcopter. 2. What does the term HAIL stands for? A. High altitude long endurance. B. High attitude long endurance. C. High altitude low endurance. D. High attitude low endurance. 3. Propellers in the quadcopter is arranged in CW and CCW pairs to avoid A. Rotation, B. Yaw, C. Roll, D. Pitch. 4. Which of the following is correct? A. Lift produced by an airfoil is always equal to weight. B. Drag by sphere is more than the drag produced by an airfoil for similar condition. C. Drag by sphere is less than that produced by an airfoil for similar conditions. D. Drag by sphere is equal to the drag produced by an airfoil for similar conditions. Five. How would you get a quadcopter to roll and move right? A. Decrease the front motor's speed. B. Increase the speed of the CW motors. C. Increase the speed on the left motors. D. Increase the speed on the right motors. 6. DGCA stands for A. Director General of Civil Aviation. B. Deputy General of Civil Aviation. C. Director General of Civil Airlines. D. Director General of Civil Authorities. https://www.youtube.com/watch?v=T9UCC2J0 https://www.youtube.com/watch?v=XL91TKG126Q